Here we're going to be looking at trig ratios for angles greater than 90 degrees. Now this seems a bit strange because so far what you've talked about is that sine is defined in terms of opposite and the hypotenuse, and cos is the adjacent and hypotenuse, and tan in terms of the opposite and adjacent. If you have an angle greater than 90 degrees, you can't have the same sort of thing. There's no hypotenuse for a start. So let's take a look at how we get around it. So we're going to do this, and we're going to use the unit circle. In other words, a circle with a radius of 1 unit, center at the origin. Let's put any points on there, x, y, and draw a line from the origin to that point, and call the angle between the positive x-axis and that line theta. If we do this, what you notice is that sine theta is y over 1, or just y, and cos theta is x over 1, or just x. In other words, we can think of the coordinates of the point xy as really cos theta sine theta. So we're now going to take that and extend that to going around the circle. So we will now consider cos theta sine theta to be the coordinates of any point on that unit circle, and the angle theta is made between the positive x direction and the line going from the origin to that point, as we see in this diagram. So what we do, we now draw a congruent triangle in the first quadrant so that we've got the same angle sitting down at the bottom of the triangle, and that's the acute angle between the x-axis and the line to the point. Now, to make life easy for us, we're going to call this angle beta. Then we know in that first quadrant that the coordinates of that point are cos beta sine beta. If we now take a look at the distances that are on the other triangle, on to the left of the y-axis, the height is still the same. So in other words, the coordinates of the y-coordinate is sine beta. The x-coordinate, however, has gone from the right-hand side of the origin to the left-hand side of the origin, but it's the same distance. So therefore, its position is minus cos beta. So the position of this point is minus cos beta sine beta. If we do the same sort of thing for 4 triangles around that origin, when we look in the first quadrant, we'll find the coordinates of that point will be cos beta sine beta. In the second quadrant, it will be negative cos beta sine beta. So the y coordinate is above the x-axis and positive. The x coordinate has gone negative because it's to the left of the origin. If we look at the third quadrant, we find that both sine and cos have gone negative, and in the fourth quadrant, cos has gone back to being positive because it's on the right hand side of the y-axis, and sine has gone negative again. So what you can see is for our angle between the positive x-axis and the line that goes to the point, we're using the angle which is the acute angle between the x-axis and the line to the point from the origin as the angle for where we actually use the triangle to get the cos and the sine. So all ratios are positive in the first quadrant. In the second quadrant, only sine is positive. Cos has gone negative, and because tan is sine over cos, tan will be negative. In the third quadrant, tan is positive because tan being sine over cos, negative over negative is a positive. And in the last quadrant, only cos is positive. So, for ratios that are positive in each quadrant, all in the first quadrant, sine in the second, tan in the third, and cos in the fourth. And there are lots of silly little things to help you remember. For us, it was, when I was growing up, all stations to central. But there again, I lived down the central coast, so that wasn't too many stations. These days, I've heard another silly trig concept, and I'm sure there's a lot more. Okay, so let's take a look at some examples. So this is the diagram that we've got. Point A is in quadrant 1, point B is in quadrant 2, point C is in quadrant 3, and point D is in quadrant 4. So let's take a look when we're in quadrant 1. Suppose our angle is 27 degrees. Then our x-coordinate is going to be cos 27 degrees, and the y-coordinate is going to be sine 27 degrees. That's one that looks familiar, feels familiar. Let's take a look at B. The angle between the positive x-axis and the line to the origin to B is 153 degrees. So in this case, our x is cos 153 degrees, which when you take a look at the diagram is going to make it minus cos 27 degrees. So you take the 153 away from 180. Similarly, sine 153 degrees is going to be the same as sine 27 because it's the same height above the x-axis. In quadrant 3, our angle theta, when drawn from the positive x-axis going an anti-clockwise direction, is 207. In other words, it's 180 degrees plus 27. In this case, both the cos and the sine are going to be negative, so x's coordinates are really minus cos 27 minus sine 27. And in the fourth quarter, we're really taking 27 degrees away from 360, which gives us 333. So cos of 333 degrees is going to be the same as cos of 27 degrees because it's to the right of the y-axis, and sine of 330 degrees is going to be negative sine of 27 degrees because it's below the x-axis. And that's the way that you do it for all of them. Work out the angle between the line going from the origin to the point on the unit circle. Take that away from 180, add it to 180, or take it away from 360, depending on which quadrant you're in, and there's your answer. So, for trig ratios for angles greater than 90 degrees, draw a small diagram. Work out the acute angle to use. Remember which ratios are positive. Complete your calculations. And that's how you do trig ratios for angles greater than 90 degrees.